Yar, I'm José Valim. Yes, so we are here to talk about design patterns in Elixir. And Yar, I work at Dashbit. We help companies adopt and run Elixir. And yeah, this talk is going to be a little different from my usual talks. It's usually like Elixir update or things that are coming to Elixir. And today there is not going to be much of that. But before we talk about like design patterns per se, there is something that happened in this direction, or at least related to the word patterns in here, is that in Elixir 1.16, we added anti-patterns to the Elixir documentation. So if you go to the Elixir documentation, you're going to, we did a big revamp in the documentation with Elixir 1.16, and we added a section of anti-patterns, right? And anti-patterns, they describe common mistakes, or they are indicators of potential problems in code, right? So you can go to this page and then there is a lot of reference around that you can navigate, right? And how do we get to this, right? How do we get to this documentation, okay? It was actually a long running process. So this was Lucas Veggi, as part of his PhD thesis and supervised by Marco Tullio. They did the work and they published papers around this. And in one of the papers, they have like this graph. And pretty much what happens is that, well, when you're going to talk about anti-patterns, if you go like to literature, to books, like to papers, you're going to find a bunch of anti-patterns, right? Those things are available. And of course, you have to go for that, but some of those anti-patterns may be, probably the huge majority is about like OO programming languages, right? So they have to see, hey, does that apply to Elixir? But also what they had to do, and I love because, yeah, what they had to do is that they also had to search materials that we produced as a community, right? Like blog posts. So Chris Kifley had a very good article where he had his opinion about what is good, what is bad Elixir, right? Bad Elixir is potentially going to be anti-patterns, right? We had a reference in the Elixir documentation. And what I love about this is that what they call is that this is the gray literature, right? Like it's a very funny term for some reason. Oh, that's the gray literature. So what they did is that they had this whole process to go for the gray literature, like go through Google, go through documents, right? And then you extract information from those documents. And what they did is that at the end of step 3, they had like, oh, we have 11 traditional smells, 18 Elixir specific smells. They created a catalog. They shared with the community. The community gave feedback on this catalog, gave idea of new anti-patterns, right? So there were a bunch of steps. And at the end, they got here, what is it? 12 traditional smells and 23 Elixir-specific smells, right? But what they did here, their goal here was to build a catalog, right? Even when they went to the community and the community said, I don't think that happens a lot, right? It's there in the catalog because their job is to build the catalog, right? With everything that could potentially be and potentially apply. So what the Elixir team did is that we got this and then we filtered it again to be anti-patterns that we think it's clear and applicable to the huge majority of cases, not like, oh, this applies only in this particular condition, this particular scenario. So we filtered it, we did another round of feedback with the community, right? Getting more feedback, we removed more anti-patterns, and then at the end, we had this list, right? We had about 22 anti-patterns, right? And we broke them apart into 4 distinct categories, and that's now part of the Elixir documentation, right? And I think this is nice. I think this is really important material to guide the community, to guide teams, library authors, application developers to go towards the proper direction, right? But then you can ask, like, what is the next step? So Lucas Veggi and Marco Tullio, they are now building a refactoring catalog, right? Which is not necessarily going to be part of the Elixir documentation. That's not necessarily a goal, right? But it's something that we can use as a community. Maybe we can integrate this into our tools, like into, I don't know, Credo, the styler from Adobe, language servers, right? So there's a lot of work that we can do when we're thinking about software engineering techniques, right, that we can apply to Elixir as a programming language. And one of the questions that I want to explore in this talk, right, is exactly about the idea of design patterns in Elixir, okay? And who here is familiar with the term design patterns, right? Yeah, we are going to get to the exact meaning of the term, so don't worry. And who here has seen this slide before? Right. So whenever design patterns comes up on the topic of a functional programming language, which would be Elixir, right? This slide pops up, right? And the source is F# for Front and Profit, and Scott showed this slide in a presentation, and of course it went viral because those things never happen, right? Like it went viral and taken out of context. And Scott says, like, look, most people, when it was taken out of context, taken out of his presentation, most people misunderstood what this slide meant, right? Object-oriented developers misunderstood. They felt like, oh, this is clearly a dig at object orientation, right? And functional programmers felt like, oh yes, functional programming is much better. There are no design patterns, right? And that's not exactly the case, right? And one of the things that we can look at this slide, one of the points is that, look, it is expected that if we're going to have design patterns in functional programming languages, that they are going to be different from object-oriented ones, okay? That's somewhat expected. But I think a lot of the discussion around this miss the point, what design patterns actually are, okay? And here's the thing, so what is a pattern, okay? So the term pattern comes from a pattern language book, and they say that each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use the solution 1,000,000 times over without ever doing it the same way twice. And that's the thing. When we're thinking about design patterns in functional programming languages, what a lot of people are doing is that they're like, oh, this solution to this design pattern, then they take the OO solution to a problem, and they're like, can I translate this OO solution to Elixir or whatever functional programming language? And it's like, no, you cannot. And they're like, oh, then the design pattern does not exist. But design pattern is not about the solutions, right? Design patterns are about problems that happen over and over again to the point where we're like, okay, this is so frequent, right, that we want to document a solution for this so everybody knows like exactly how to tackle that problem. What are the pros, what are the cons, what are the trade-offs, right? And then we have things like this. Sometimes something becomes so common that we add a solution to the language, right? We're going to go back to this, but we can think that things like Jump Server, supervisors, they are like design patterns because when they were working on writing those applications, like, oh, this problem is recurrent, so let's add an abstraction like a supervisor to give us like fault-tolerant design properties, okay? So with that said, like, so we really want to think about the problems. This is a discussion about problems, okay? With that said, the goal of this talk is to go through the design patterns book. Okay, it's called Gang of Four because of the 4 authors. And why this book? It's because it's the most well-known design patterns book, okay? So it's a good reference. But we can see in the subtitle, right, these elements of reusable object-oriented software, right? So what we want to do is that we want to focus on the problems, right? We won't be translating solutions. We'll think about the problems. We'll think like, hey, does this happen in Elixir? And if it happens, how do we solve this? And then we can get to a solution. Who has read this book, by the way? Wow, okay. And there is a limitation, and we'll come back to this again. The goal of this talk is not like, oh, José delivered the design patterns for Elixir, right? That's not the goal here, because it's only a single book, right? We saw in the anti-patterns how much work it actually is to build a catalog of anti-patterns, right? And at least the same amount of work would have to be put if you want to get to a collection of design patterns in Elixir, right? So this is not meant to be a complete reference. It's a complete collection. It's literally the interpretation, let's say, of a single resource, one single book, a very influential book. All right, are we ready? Yeah. Let's do this then. So, since you are ready, here are 23 design patterns that they are in the book, all right? But of course, we're not going to go over all of them. We don't have time to go over all of them, but we're going to do some of them, okay? So I'm going to pick one, right, for us to get started, for us to warm up. The mediator design pattern. So the book has diagrams, and And what is really nice about the book is that it also has a lot of the examples there are about like graphical user interfaces, like old graphical user interfaces, because the book is 30 years old, but a lot of the ideas apply, right? So they have this example here, which is, look, we have a graphical user interface for selecting a font. So you can select the font family, and then you can select like font style, and then you can choose the weight, the length, the size. And the thing about when you're writing this interface, one of the issues that we have with it is that depending on the font that you select, like some of the weight options need to be disabled. So here we have like demi-bold disabled, right? Or depending on what you select, you're going to have different options for the size, right? Basically what it means is that in order for you to implement this, one of the ways you would implement this is that you would need to, one input knows about the other input, so when one input changes something, it needs to go notify to the other input that something changed. So you have a bunch of inputs referencing each other because whenever you click something, the other needs to know about it, and they're like, this is quickly going to become messy software, okay? So they say, okay, so that's the problem, right? And the solution, without going to details, right? What would be the solution to this problem? Like, okay, we're going to have like an entity. So of course, in that book, that entity would be objects, right? So let's forget about that for now. But they're like, okay, we're going to introduce an entity here that is responsible for mediating things. Instead of input knowing about the other input and so on, everybody just talks to the mediator, right? And then the mediator is going to do the job of like, hey, input, you need to change this. Hey, input, you need to do that, right? So it's a mediator, okay? Do we do this in Elixir? Like, can somebody give me examples of where you would use mediators? Agent server? Yeah. More examples in your web apps? Just shout it. Yeah, go ahead.
Live component,
live views? Yeah. Anyone else? Right? Yeah, that's exactly it, right? Like agent server, because a live view is agent server, or a Phoenix controller, a Phoenix live view, right? A Phoenix controller, we can see it's a very straightforward mediator, right? Because it has no state. So it just kind of like, but it's mediating between like, we don't want our templates and our views to be directly calling the models, right? We don't want that, right? So we're like, we are going to introduce somebody here to be in the middle, to get things from the domain, right? And send that to the view. Controller is really straightforward mediator, right? But when you start thinking about stateful things like a Jun server or a live view, then that's a proper mediator, right? We are receiving events from the browser, right? We are receiving events from our domain, like, something updated in the database, right? And then we are rendering new things, right? So it's really mediating a lot of things, right? Imagine if the way we're writing our Phoenix web apps is like, whenever you create a new user in the database, you are like, I want to update those tables, and your domain code was like directly updating HTML tables, right? That would be very messy, right? So yeah, like, look, we do have a design pattern, right? So mediator, how do we do this in Elixir? We use functions and modules, right? The stateless version, like, just functions and modules for controlling and coordinating logic, or we bring processes for controlling and coordinating events, all right? So first one, we did it. We do have at least one, okay? So let's do another one, facade, okay? So what is the problem? Imagine that you have I don't know how well you can see this, but imagine that you have, so those are diagrams from the book. Imagine that you have a subsystem which is in this big rectangle, right? So you have a subsystem, and you have different parts, different modules of your application, for example, that needs to talk to the subsystem, okay? So you can see that these, when you look at it, starting to get very messy, right? Like, you have the subsystem and a bunch of components talking to all those different parts of your subsystem, right? And you can think, like, for example, each of those smaller rectangles is like a module, okay? This starts becoming very messy, so they say, well, the idea of a facade is that we are going to put, instead of allowing the world that's outside the subsystem to talk to the individual components, we are going to put a module here in the front, and everybody has to talk to this module instead, okay? That's it. Can you give me examples? Context, right, yay. A golden star for everybody, exactly, right? Like Phoenix context, that's the main goal. It's like, okay, this thing can get like complex. I'm going to create a facade around this, around the data, right? And all the complexity can have here. And pretty much many Elixir applications are doing exactly this. Like if you go to the logger, the main API that we use is a single module, right? But internally, Logger has a bunch of other modules that you don't know about. Right? Like the Elixir compiler is like 15, 20 modules. But for us, using Everyday, it's the code module API, right? So yeah, like this is extremely common. This is extremely common design pattern, right? And the solution in this case are modules. Provide a simplified API to the more general facilities of a subsystem, okay? All right, we got 2 in the bag. Okay, let's do another one, strategy. All right? So, who can read those diagrams? Please raise your hand. All right? We won't have to read this. I'll explain the idea, okay? So what is the problem that they describe in the book where they say we need to introduce a strategy? So what they're saying, look, imagine that you have a string with no line breaks or anything, for example. You just have a large string and you need to render that string on a screen. Right? So you need to compose, they call it compose. You receive some text, you receive the dimensions, and then you need to render that thing within that dimensions. They are calling it composition. And what they are saying, so you have to know, like, so for example, if you're rendering something for like print, you probably want to justify the text and you want to have like a different heuristic. But if I render it for a screen, maybe you can break the text differently. So the idea is that you want to compose text, and you may have different ways you want that text to be composed. Okay, you have, you need like different strategies. So the example that they come up here is that you're going to have a single compositor, a text compositor, or an array compositor. I was pronouncing that wrongly. Yeah, but you're going to have like 3 different compositors, and then you need to choose those. Okay, so how are we going to solve this problem? Like if you're thinking about Elixir, this is kind of like when we're thinking about how we're going to solve this, right, in Elixir, we're kind of thinking like this. Oh, I'm going to have a compose function. It receives the text and the dimensions, right? And then we want to pass a strategy, okay? So we can control how that composition function works. Okay, we're good? So how are we going to do this? Well, there is one solution, okay, which is let's use pattern matching. We say that the strategy can be like 3 different atoms. It can be like the simple atom, the text atom, the array atom. And then based on that, we are going to call a different function that's going to do something differently, right? And this is a perfectly fine solution. And maybe somebody's going to be like, no, look at this code, it's all coupled. Everything is in a single place, right? And then I'm like, no, this is completely fine, right? This is completely fine. I like to say that decoupling is not self-serving. We don't decouple software because we have to decouple it. We need to have a reason for decoupling because decoupling is going to introduce complexities, right? And we are going to talk about this, right? So if you can escape with this, you can like, oh, I'm just going to receive an argument and customize my function, then yes, do this, right? Go ahead with this, okay? But imagine that you say, look, this would be ideal, but it came a requirement, maybe you're doing a library, or it came a requirement that you want to allow anybody to pass the strategy. Because in this code, what is this issue with this code? You only know about those 3 strategies, right? If you want to add a 4th strategy, you have to change the code. So it gets to a point where you're like, look, I want to allow anybody to just pass the strategy. What do we do? How do we solve this problem? We use an anonymous function, right? We use an anonymous function and say, look, you can pass a strategy, right? And this strategy is an anonymous function. And the thing that now we decoupled it, but there's a complexity in here, which is now we have to define a contract. We need to say, look, this function is going to receive this argument of this style, and it must return arguments of this style, right? So there is a contract now that you have to define and maintain, right? And then when you're coming up with this contract, you come up with the wrong contract, then you have to manage that in the future. So there is complexity, but we are getting decoupling out of it, right? So if you say, look, it's an anonymous function, now you can compose with functions, right? So say, oh, I have a simple compose here that just builds on top of compose, passing an anonymous function, right? So we can do function compositions. And I think about that slide, it's like, oh, everything is with functions, right? It's exactly about those ideas, how we can solve like how we can pass an anonymous function as a strategy, right? And we get decoupling and we get a lot of flexibility out of this very small change, okay? But this has issues as well, right? What is one of the limitations here? Well, what happens if the way to customize the text composition requires more than one anonymous function, maybe 2, 3, right? Are you passing now like 3 distinct anonymous functions around, right? It can start getting complexity. So it gets to a point where in the book they're like, okay, so in this case, what you may want to do, so this, I know I said we're not going to translate solutions, but the book it says, the way you're going to solve this, right, in object-oriented languages is using interfaces, right? And they say strategy is any object that implements the composer interface, okay? So let's think about this, right? In order to think about this, what are interfaces in Elixir, right? I was not expecting answers, but this is great. Tell me. Behaviors, but protocols. All right, let's see. So I've been thrown out of my loop in here because I was going to say before we can answer what are interfaces in Elixir, we need to answer what are objects, okay? So we'll come back to that, all right? We'll come back to that. All right, so what are objects? So from the Elixir developer perspective, I like to think that objects is the coupling of the space coupling, okay? The coupling of 3 things. Behavior, state, and mutability. And we can think mutability time, right? Because every time you mutate an object, it's the same identity, but with different values. So for that to happen, like, you need to have like this concept, this abstract concept of time. We're going to call it mutability, right? Objects couple those 3 things, right? Every time you create an object, you get those 3 things, right? It's always there, right? And we are going to see that some design patterns, they exist exactly to address the fact, like, oh, I don't need the 3 things, I only need 2, so I'm going to deal with that, right? So object is the coupling of those 3 things, and we're going to see that sometimes this coupling introduces issues. But to me, the biggest issue of this coupling, the biggest example of the issues caused here, is inheritance. Who have here programming a language with inheritance? Okay, right? Because what is the issue? So imagine that, okay, we have objects, and then the objects couple, like, for example, behavior and state. So now you're like, oh, I want to add new behavior to the state. One of the ways that you can do this, right, is they're going to say, oh, you can now inherit from that class or from that object. You can now inherit and add new behavior to it, right? And you're like, okay, problem solved. But the issue is, what is one of the classical definitions of objects? Is that they exist to encapsulate state. They encapsulate state, so when you interact with the object, it can change its inner state, right? And you don't know about it. But when you add inheritance to a programming language, you just introduce a mechanism where you can break this encapsulation and access the internals of the object. So they're like, I know. What we're going to do then is that we're going to introduce like keywords like protected and final, so we can control the visibility of the thing you're not meant to access in the first place, right? So you have a problem, and then you solve that problem, and that brings other problems, and then you try to solve that, right? So when do we stop, right? And then you have to think about things, oh, what about multiple inheritance, right? And those are problems that they come from this coupling, right? And you can think like, oh, of course José is going to be saying that, right? Like he created a functional programming language. Actually, all of those things, they talk about it in the Design Inspire book 3 decades ago, right? And they say, favor object composition over class inheritance, right? Except that I would change this. I would say like strongly favor, right? I would say, like reject class inheritance in favor of object composition. And it's really, and you know, functional programmers, they have been building large complex systems without inheritance. And it's really nice to see that, you know, new programming languages like Rust and Go, right? They only have the composition flavor, right? They don't have the inheritance flavor of things. It's composition. They focus on composition, okay? So how do we get composition? Interfaces, all right? So imagine that you have object A here with its own behavior, state, mutability. You have object B. It's a separate object with different behavior, different methods, different state, different mutability, okay? And you have object C now, and this object needs to communicate, needs to work with both object A and object B. How do you do this? So in many of those programming languages, you do this by defining an interface. The name doesn't matter. You can define an interface fullbar, and you say, look, as long as object A implements this interface, object C can work with it. If object B implements the interface, object C can work with it, and any other object. So you say, look, as long as you implement the interface, I can work with you, okay? So interfaces, they are a mechanism for polymorphism, right? And polymorphism means poly, which is many, and morph shapes. So it's a mechanism where you can work with different shapes, right? With many shapes, right? And the idea of interface is that there is an upfront contract, okay? So an interface you declare upfront. Other programming languages like Ruby and JavaScript, you usually don't define those contracts upfront. We say like, we have duck typing, which you just do the thing that you want to do. Interfaces are upfront. So with all that said, what about Elixir, right? So what is Elixir? Now we know what are objects from the Elixir perspective. So how Elixir tackles this? So you can think about Elixir is that, yes, we do have behavior, we do have a state, we do have mutability, but what we do is that those things, they're not coupled to each other. They are decoupled, okay? So modules is how we have behaviors, right? Data is how we have a state. And processes introduce mutability, right? Or a vision of mutability, okay? So we decoupled, and this is great because now we can build softwares, we can build programs from principle. Oh, to solve this problem, I only need data and modules. I'm just going to do that. I'm not going to get a process involved on that, right? So we can pick the building blocks that we need and build everything on top of that. And as you're going to see, there are benefits to this. So now we can say, what about polymorphism in Elixir? So what is the translation, right, of interfaces to Elixir? Because we have 3 different dimensions, right? We actually have polymorphism in each of those dimensions. So for example, if I want to have polymorphism over modules, I define a behavior. And look, if I want to say, look, your code can give me any module as long as it implements this behavior, right? And that's how we have polymorphism for the modules dimension, for the behavior dimension, right? Oh, what if you want to have polymorphism over data? You can define and implement a protocol. And then you can say, oh, you can give me any data as long as you implement this protocol, okay? And you can also say, look, you can also do polymorphism over processes, right? And this is the most dynamic, the most late binding of them all. You can say, look, you can give me any process as long as this process sends and receives those messages, right? So we have 3 ways of doing polymorphism in Elixir, 1 over each of those dimensions, all right? So, and then modules and data, behaviors and protocols, we have a upfront contract, right? But for processes, we don't do that. But you can always wrap the sending of messages in a behavior protocol if you want to have an upfront contract. All right, where are we again, right? So, quick detour, we can go back to our design patterns. So, strategy, right? We're talking about the strategy design pattern. So yeah, we can start with pattern matching, and if this works, ship it, okay? And then, oh, now we need to make it customizable. We want to make it extensible. Does an anonymous function solve it? Oh, it solves it. Ship it? No, we have to pass like multiple anonymous functions around, starts getting messy. We bring a behavior, right? And then we say, look, the strategy can be any module as long as it implements this list of callbacks. In this case, a single callback, which means it could have been an anonymous function, but if you have multiple callbacks, right, you can just pass multiple callbacks. And now we call compose here at the bottom, passing different modules, okay? So this looks great, right? We can use behaviors. But, well, José, what about protocols, okay? Should we use protocols for solving this? And this was actually, preparing this talk and preparing this part of the talk was very insightful because I had kind of informal rules. It was, I had the rules in my head and in my heart, I guess, of when you use behaviors and protocols, and thinking about this, thinking about those constructs, I was like, well, you know, we generally prefer behaviors, right? And the reason for that is because we should only rely on protocols when our goal is to compose and encapsulate data types, especially the built-in ones. If you want to add behavior to the language in a way that it applies to several data types, including the ones that come as part of Elixir, the built-in ones, integers, maps, strings, that's when it makes sense to implement a protocol. And we could do that, right? We could define a protocol, okay? And we could say, oh, I'm going to accept anything. Oh, the protocol definition is wrong. The argument order is wrong. So here at the bottom, think that the struct is actually the first argument. I'm sorry about that. But yeah, we could define a protocol, right? And then have the same idea. Now it's customizable. You can give me any data structure as a strategy as long as it does this, okay? And also, we can ask, should we use processes as well for our strategy? And again, I think we have a very clear rule here. We should only use processes as our strategy there, as our way of doing polymorphism, if the system is stateful by design, right? So in this case, a strategy is most likely not stateful. Like we just need to compose text. There is no state in there, right? But if the system is stateful by design, so for example, all I/O in Erlang, so the things that Chris was talking about in his keynote, oh, we can just pass file around, right? That's because a file is a process, right? And all I/O in Erlang is done by message passing, right? Because yes, I/O is stateful by design, right? So it makes sense to model that using processes. So at this point, it's like, okay, Jose, you said that, you know, Elixir breaks those 3 dimensions apart, and that sounds like very exciting, right? It's like, oh, we can build software like from scratch, from the abstractions, we can get only what we need. But now it's like to solve this problem in other languages, I would just use an interface. And now you're telling me that there are like 3 different things I can choose. Like it can be a behavior, it can be a protocols, it can be processes, right? So how to make sense of this? So I want to quote my favorite programming book quote ever, which comes from this book, Concept Techniques and Models of Computer Programming. And it says this, rule of least expressiveness. When programming a component, the right computation model for the component is the least expressive model that results in a natural program, okay? And the idea here, one way that we could translate this, it's not a fair translation, it's like use the simplest abstraction, right? That's what this is saying. But I think like that results in a natural program, I think that part is also important, right? I don't know if you've seen like, if you heard like there is something called simple English, which is the English language, but like with simplified rules. And it happens that you think, oh, it's going to be simple, it's going to be better, but it happens a lot of the text is actually harder to read or longer when you use the simple language because you lose expressive power, right? And I think like that's the trade-off here, right? If we have a language that is too simple, we lose expressive power to solve some problems, right? And those problems usually manifest when building, when composing components or building large systems. So okay, rule of least expressiveness. So what should we do? Again, what we can do is like, look, pattern matching, the solution number 1, right? That's the simplest, it's the least expressive, still very expressive for us, but it's the simplest. If you can do it, use it, right? Oh, anonymous functions, a little bit more expressive, right? Less simple, but if it solves the problem, use it. Rule of least expressiveness, right? Then it comes behaviors, then it comes protocols, and then processes with message passing, right? So use the simplest one, right? The least expressive solution that solves the problem naturally. All right, so with this in mind, right, we can go back to design patterns, and we did 3 design patterns. And my suggestion is because we have those 3 dimensions, I would classify the design patterns over each of those dimensions, right? So facade is about modules, apply to modules, right? Mediator applies to modules like a Phoenix controller and to processes, right? And then we have the strategy one, which applies to modules as well. So we have 23 design patterns, and it has been more than half of the talk, and we did 3, right? I told you we can't make them all. We can go through all of them. But we can go much faster from now on. We have the foundation, right? We figure out what we need to do, right? We've been through a couple examples, right? So for example, one of the things is that 7 of the design patterns, we can just rule them out because those are not problems that would really apply to Elixir, right? They are like trying to solve something related to inheritance, for example, or try to address object limitations. I'm going to give one example. Can't go for all of them, but I'm going to give you one example. There is the flyweight design pattern, okay? And in the book, it's like this. Look, we are rendering text in a screen. There are 2 columns, okay? So you're rendering some text. There are 2 columns, and you have rows of text, right? And in each row of those texts, you have characters, right? You have each letter, the characters there, right? And imagine they're representing each character as an object, okay? So you have like this messy, let's not say messy, but you have like this diagram here, right? You have this problem and how you would design it, how you would solve this, right? And what they say in the book is, look, if every time, so remember, we are printing something, right, on the screen, right? And each character is an object. And then they say, look, if every time the letter A appears, we instantiate a new object, that is going to be very expensive, right? We're going to run out of memory, right? Because imagine how many times the letter A appears, each of them is a different instance, allocating their own memory and so on. That is going to be very expensive. So they're like, okay, to solve this problem, we are going to define a pool of characters, and every time we want the letter A, we just get it from that pool, so we only instantiate it once, right? So it comes up with how you're going to, again, it's a potentially a common problem, so they outline the solution, right? And the reason why this is a problem is because if you take an object-oriented language, and you're like, and you say, look, I want the character for the letter, I want the object for the letter A, you can write code like this. You can have a function that, called A, and when you call it, it returns the character. But because this is an object, every time you call this function, you get a new instance of that object, right? Every time you call it, it's a new instance, right? Because it has to be a new instance. Every time you have an object, because each of them can mutate, can change, you need to make sure that each instance is going to evolve over time differently, right? So every time you instantiate an object, because it mutates, it can change, it has its own place in memory, okay? And why is this not a problem in Elixir? Because if you're going to write the equivalent code in Elixir, okay, you would do this, right? So you have a function A, and then you define a character struct. Our character struct is just data, right? There is no behavior attached to it. There is no mutability, right? It's just data. So when the compiler looks at that, it's like, oh, you have a struct, and there are no expressions, no variables when associating the struct. The compiler automatically looks at that and says, oh, I'm just going to create one instance of this thing here in memory, and now every time you call the function A, I'm just going to point to the same place in memory. So the whole solution that the book's talking about you have to build, the compiler does that for free for us. All the code that we write, right? So like, oh, your Phoenix template is full of strings. Like the compiler is automatically getting those strings, pointing to one place in memory, and it's optimized. Everything just works. We don't have to worry about it, okay? And we even have APIs for like, if you need to define the characters dynamically for some reason, we have APIs for creating those things that are shared between everybody, right? Between all the processes, between our whole application, right? So we get this thing for free. It's absolutely for free, okay? And it's funny because many object-oriented languages, they later introduce concepts like records or structs exactly so they can benefit from those optimizations, okay? All right, 10 out of 23, we're able to rule 7 of them out. I'm going to do just a couple more, okay? So another one is that I think some of the design patterns that the book talks about, for us, it's very straightforward thanks to pattern matching, 4 of them, okay? And about the way we think about data and we reason about data. So I'm going to show another example just for us to discuss. So here's the example they have in the book. We have to implement a regular expression engine, okay? We have to implement a regular expression engine. So you think like, this is our regular expression. So this is saying, look, I'm going to have a literal raining, so I'm expecting a text with raining. And then there is the sequence character, the ampersand, that says, and raining must be followed by dogs or cats happening 0, 1, or many times, right? So the string raining would match this, right? The string raining dogs would match this, raining cats would match this pattern, raining dogs, cats would match this pattern, raining dogs, dogs would match, raining rabbits would not, right? So that's the idea. So imagine that we want to receive this regular, this pattern, like this regular expression kind of thing, right? And we need to parse it, we need to compile it, and then we need to match against some text and say if the text matches this pattern. That's our job, right? And they're like, okay. And then they come up with a whole solution on how we are going to model this, how we are going to solve this problem in an object-oriented language. So they're like, okay, we are going to have a sequence expression, right, which is the ampersand, and then we're going to have a literal expression, so they define like different objects, and because those objects, they may actually share things with each other, why not define a class hierarchy to go with it, right? So they define the whole thing, how we are going to solve this, okay? How do we have these problems in Elixir? Yeah, we could implement a regular expression engine in Elixir, right? And how are we going to solve this in Elixir, okay? It will be like this. So the first thing is that we would have to parse this, right? We'd have to parse this input, like our pattern, like it's going to come a string. And then we're going to parse it, and we're going to represent it like this. That whole graph with objects pointing to this, right? It's this. We just define tuples, like, oh, it's a sequence. The sequence has the literal raining, and then what comes, the other part of the sequence is going to be a repeat of dogs and cats. That whole class hierarchy, the objects pointing to each other, that's it. It's tuples and strings, right? And atoms, right? That's it, right? And then they're like, oh, now I have to interpret now we have to imagine somebody passes an input that you need to interpret and say if it matches the input. Yeah, you just use recursion. You do some pattern matching. Oh, if I have a sequence, that is what I'm going to do. If I have this other thing, this is what I'm going to do. You define the pattern matching with the function heads, and that's it. All those diagrams, boom, gone, right? This is it. We model the problem with data. We write some recursive functions, and we're good, right? And I think, and when I was working on this talk, because we hear a lot about people like, oh, I love pattern matching in Elixir, right? Which, by the way, just copied from Erlang, right? But we love pattern matching in Elixir. And I realized that it may be the reason why we love it so much. Like, it's great to look at pattern matching like this, right? But I think part of the reason we love it so much is because of the data modeling that it enables us to do, right? And yeah, so I'm going through this thing, like, okay, so this solution here with Elixir is much simpler. But now there is a question here. Is this a design pattern in Elixir, right? Because we can say, oh, the solution is so simple, right? Is that a design pattern? But remember, design patterns, they're not about solutions. They are about problems, right? And it's not about simplicity either. Like the mediator was super simple, facade even simpler, right? And we said that those things are design patterns. So I would say that the interpreter should be a design pattern. Those are, when thinking about how to interpret or do or parsing and input, like these sort of problems, those are things that appear. And I think like, it's actually the opposite. The solution is so elegant that I think we should rather talk about it, right? We should just be talking about it more and showing more and more, yeah, this is a problem, and it's a very straightforward solution, and we should document it, and we should talk about it. So for me, that's another design pattern, okay? We are almost done, I promise, okay? So let's do a couple more. There are some design patterns that exist for polymorphism. They are design patterns to say, oh, when you're working with polymorphisms, behaviors, protocols, or message passing, sometimes you run into problems. How would you solve those problems? So for example, one is the adapter pattern, right? And what is the adapter pattern? Imagine that you have a data type that implements a protocol, and it has to implement, and you want to implement another protocol for it. If you can use this protocol to implement this protocol, that's the adapter pattern, right? It's literally adapter, right? Like a power adapter, right? You're converting one thing from the other. So when you convert a behavior protocol or process into a new one expected by a client by wrapping it, that's the adapter. There is a decorator one, which is when you augment a behavior protocol or processes by wrapping it, right? You want to add new behavior, you want to augment, right? And this is the general meaning of behavior, right? Or you can have the proxy one, which is when you want to control access to a behavior protocol or processes by wrapping it. So they're all very related to each other, right? They're all about how you're going to compose behaviors, compose protocols, compose message passing, but the reason why we are doing it is different. That's the idea, right? Should it be three different things, right? I think that could be a good discussion. I'm not going to enter into that discussion right now. Let's just say, okay, those are three different design patterns that, yeah, they do make sense for Elixir. I have used the proxy, I have used the creators, adapters. Yeah, sounds good. All right. And the last one that I want to talk about is the observer design pattern. Not to be confused with the observer tool in Erlang Elixir. And what is the problem here? So imagine that you have some variables here at the bottom, okay, at the bottom of the screen. You have some variables. And imagine that whenever you change the value of those variables, so those variables, like you have 3 variables, A, B, C, with different percentages, okay? And like whenever you change those variables, you need to update some tables, you need to plot some charts, plot a pie chart. That's the idea. And the book is saying, look, you don't want necessarily for the code that is handling with the variables to know that the table exists, right? To know that the chart exists. So you want a mechanism that, whenever those variables change, other parts of your application, of your software can change without the variables knowing about those things. Okay? Do we do this? Where do we do this? Do we have examples of this in Elixir code? PubSub, fantastic. All right, yeah, that's exactly it. We do use this. Phoenix PubSub, registry, telemetry is another example, right? Yeah, so this is a common problem, right? We are doing this in our applications, right? It's a common problem, and we have common solutions, right? Often message passing across processes, right? And what is really interesting about this is because when we're talking about the observer, because processes are involved, right? They are usually involved in an observer in PubSub. It starts bringing the discussion that, some of our design patterns, they actually relate to concurrency, right? And what is really cool is that not only about concurrency, but it's also distribution. We can actually have one node in our cluster and have an observer in another node of our cluster, right? And that works. And that's what we are doing with LiveView. Right? A live view, we can have we have one node that changed the database and it notifies something to another node to pick it up, right? And that's when you realize that it's all connected, right? Phoenix Live View is a mediator that utilizes the observer design pattern to update clients in real time. All right? Got it? So, design patterns in Elixir. So if we go through everything that I talked today, right? There are 8 in here, and I've put the check marks, right? I'm going to make these slides available later. And actually, while preparing this talk, I went through the whole 23, and this is my interpretation, okay? And I want to be clear about this. This is my interpretation of the design patterns. If you like this, you can go home, go through the book, think about those things, and come up with your own design patterns, and we can compare notes later, okay? And what is really interesting about this is that there are some design patterns that I looked at them, and I was like, this could happen in Elixir. I could see this problem happening, but I don't remember ever facing this problem in my programs. I never remember reading a code trying to solve this. So there are some that, we could think, it could apply to Elixir, but because I didn't see it, right, it does not classify as a recurring problem, right? That's probably worth talking about. So I ended up with this 10, okay? So to sum up, design patterns are applicable to Elixir, right? And perhaps more important, I really wanted to share this idea where Elixir decomposes objects into 3 dimensions, right? And we are free to pick the dimensions we want to work with when solving our problems. Sometimes you just need data, and then it just uses data, and that's fantastic, okay? We're not getting these objects with everything bundled, and you have to pass all those 3 things coupled all the time around. And then we have behaviors, protocols, and message passing as tools for the coupling, right? And when you are not sure which one you should use, go with the rule of least expressiveness, right? Those are tools for composing our application, right? So we can decouple things, right? They help when composing, when building large systems. And where to go next, okay? Again, this was one book, right? Was one resource. And we should do many more resources, like from literature and from gray literature, right? And then we need to talk about how come are they in practice, right? I went through those things, and that was my interpretation, how common they are to me, but you may have a different experience. But to me, the most exciting about this, which we started to see when talking about the observer, is that we should also talk about patterns for concurrency, distribution, and fault tolerance, right? And it's nice to realize that many of those patterns, they are already part of the language, right? Like task, right? It's a problem so common that is like, oh, this thing is right there into the language, right? Agent, jump server, right? Supervisor is a pattern for fault tolerance. But it's not all of them. We have a bunch of other patterns for building concurrent and fault-tolerant software that we should talk about it. We should document it, right? Those can also be occurring problems that we need to have prescribed solutions for. That's all I had to share for today. Thank you very much.
Okay, we have time for some questions here, and I'll read the ones that we have online. Elixir codes are meant to be faster, but if we follow polymorphism, no doubt the reusability increases, but it won't add to complexity of code and have performance issues like other object-oriented programs. Does that make sense?
I'm not sure. Yeah, so the question is, if we use polymorphism, wouldn't that affect the performance of the program? I mean, it would if you're using it when you don't need it, right? I mean, like you're going to introduce polymorphism to our programs because you need polymorphism, right? That's the point. If you don't need polymorphism, don't introduce it. And then if you need polymorphism for that problem or program, then you need it, right? You need it, right? You have to introduce it. So yes, like it's going to introduce a little bit of interaction, right? But like a behavior, for example, and I forgot to talk about this actually. A behavior, for example, it's very cheap, it's very lightweight to invoke a behavior. And a protocol is not much more expensive than that. So yes, like can it become slower? Yes, it's going to become a little bit slower, but it's like, we're talking like sub-millisecond kind of thing, right? I don't think at the end of the day it matters much, because that's one of the things that I forgot to talk about is that when I was talking about this graph here, right, where we show the things, like the complexity of the simplicity versus expressiveness, is that this also match how frequently we use those things, if you think about it. Pattern matching, we use all the time, right? All the time. Anonymous functions, we use a lot as well. Behaviors, we also use a lot. Maybe you don't notice it, but we use behaviors a lot. Your endpoint is a behavior. Your controller is a behavior. Your router is a behavior. Plugs are behaviors. Your Phoenix Live View is a behavior, right? Your controller, did I say controller already? It's a behavior. Your repository is a behavior, right? So we use behaviors all the time as well. And then we use protocols, but less than behaviors, and we use message passing as a mechanism for polymorphism, even less. So I think, yes, the direct call is always going to be faster, but it's not like our tools for polymorphism are going to be much slower. So if you're thinking about cost, I would not worry about the performance cost, but the cost that is in this chart, right? I would be much more worried about, when we are using protocols when we don't need, when we're using message passing for polymorphism when we don't need, the cost is actually in simplicity, if that makes sense.
Thank you. Next question. When are you writing an Elixir patterns book?
Nope.
All right. The book's patterns were applied to any OOP language. Do you think an interpretation of it would be applicable to any FP language?
That's a good question. I'll have to think about it, but I won't think about it. So for me, the goal of this talk is I think this is a really good question, and the goal of this talk is to start this discussion. I know there are people that are excited about those discussions, and hopefully this gives everybody food for thought on your travel back home and so on. And you can think about those things and maybe think about answers to questions like those, like how general what we discussed about Elixir actually is.
Okay, let's do one more. Is there any way to have, you're going to love this, is there any way to have Guard to get a module that implements a behavior?
Oh, was it user? Yeah. So the question is like, is there a way for you to the person who has said guard, but is there a way to express in our code that, look, this argument that I'm receiving is something that implements a behavior? And because it's not possible in TypeSpec today, and we don't have guards for that as well, but we have been working on a type system for Elixir, and that's something that we would like to express, for example, in the type system, if that's possible. So for those who read the type system paper, that's like one of the things that we want to explore in the future. We don't have the research, the academic, we don't have like the foundation in type system yet, but that's something that we want to explore and bring this capability to Elixir if it all works out. So it's under research, yeah.
Well, thank you very much, Jose. Let's give you another round
All right.
of applause.